Hi guys, welcome back to the lab. This is part 6 of my Honda S2000 AP2 transmission rebuild. In part 6 we're going to be talking about the secondary shaft preload adjustment, and here's where we're going to be working. Right here in front of us we have this section. From here to here is the transmission housing, and from here on up is the rear housing. So this is the secondary shaft inside the rear housing, and so we're going to be taking a look at that. This is part of the rear shaft, or the secondary shaft. This is actually the companion flange, which is attached to the secondary shaft. Let's take a look at the exploded view. Here's what the exploded view looks like. So here's the companion flange that I was just pointing at, and it goes through the rear housing and it attaches to the secondary shaft right here. So there are two roller bearings that we're going to be adjusting the preload for. It's this guy right over here and this guy right over here. And how we go about adjusting the preload is by adjusting this shim right here, this thickness. And the reason why we do that is because the tapered roller bearings have to have a certain preload to ensure proper operation and optimal performance. So now back to this secondary shaft right here. To check the preload, we have to check the running torque of this flange right here, the companion flange. And it has a certain stiffness to it, and that's all determined by that shim that I showed you. So the requirement is 16.5 to 25.2 pound-inches, and all we have to do is check that with a torque wrench that can check running torque. You can either do it with a dial torque wrench or with a digital torque wrench. So the key is, if the running torque is above the specification of 16.5 to 25.2 pound-inches, then you have to go with a shim that is thinner, so that way the running torque will go down. If your running torque is too low, you're going to have to go with a shim that is thicker, and that'll increase the running torque right here. So the shims that we're talking about again are this number 8 right here. That's the shim that we'll be switching out. So if you look in the OEM service manual, you'll be able to tell all the different sizes that they have. They range anywhere from 0.03454 all the way up to 0.0579. So that's 35 thousandths all the way up to 57 thousandths. So I'll talk about how to do that in a second. To check the running torque on the secondary shaft, we need a dial torque wrench or a digital torque wrench that can read running torque. I'm using a CDI torque wrench. This reads 0 to 75 pound-inches, and it is a quarter drive, so I had to use an adapter here. So this is a quarter to 3/8, 3/8 to half, and this is a 36mm socket. Now I'm going to take this guy and I'm going to put it onto the secondary shaft. And I'm going to read the running torque here, and it looks like it's a little bit over 20 right there. And this is after I put in a new shim, a thinner shim. And then to read it the other way, we'll just flip this gauge around to right there. Turn the telltale around and put it back on. Now I'm going to rotate it counterclockwise. Let's see where it's reading. It's just a little bit over 20 right there. So that looks pretty good. Okay, so now let's talk about changing the shim. To change the shim, you have to remove the rear housing. There are 8 bolts. There's 2 long ones and then 6 shorter ones. And they are M8 by 1.25. Here are the 8 bolts. So 1, 2, 3, 4. Those are short guys. Here's a long one right here. And then there's a shorty, shorty, and a long one right there. And so those are your 8 right there. Now, after you get those bolts off, you're going to lift this whole section straight up because there's 2 pins. And if you don't lift it up straight up, you're going to damage something on the inside. It's an oil guide and it's plastic. So lift it straight up. And then you're going to use your 2 hands and you're going to lift the outer bearing race out of the transmission housing, remove the shim, and put in the new shim that you need. Make sure that it's pre-coated with manual transmission fluid, and then you're going to install the outer bearing race and ensure it's concentric when you put it in, and then you're going to clean both flange areas on the bottom of the flange areas where they connect here. You want to clean this flange and this flange before you put them together. I clean them off with acetone, make sure there's no debris on them. Otherwise, it's going to mess it up. Then you're going to put these 8 bolts back in again. You're going to torque them in the specified pattern that's called out in the manual, and you'll do it in 3 steps. 10 pound-feet, 15 pound-feet, then 20 pound-feet. Then you'll check that running torque like we just did. Now I'm going to do it in real time. Okay, here we go. We're going to change the shim. We're going to remove those 8 bolts. And flip this on its side so you can see what's going on. I'm going to do these guys. And I'm also going to do these 4 right here. I'm going to do it in a crisscross pattern. Now I'm just going to remove them. I'm going to remove them just a little bit so that way I don't tweak anything out. Once they're all removed, I'm going to blast them completely out. Okay, removing all the bolts. Okay, don't forget, you have to lift this section out with 2 hands. Be careful and lift it straight up. Okay, I'm going to put this aside for a second. Before I put it aside though, there's the tapered roller bearing. It fits right into this outer race right here. Okay, so now I'm going to remove the outer race using 2 fingers, and I want to lift this straight up, and I want to lift it out concentrically, and then it should just slide right out, just like that. And there is the shim that you're trying to replace. This is actually the right side shim, so you want to check the size on this guy. I already figured out which is the right one. This is the correct one. My original one was thicker than this one. This one is this one reads 40 thousandths and 7 tenths. So my other one was 43 thousandths, and so the running torque was 30 inch-pounds on that thing, way too high, outside of the spec, so we're going with this thinner shim. So again, recoat this thing, make sure it has MTF on it, you coat it, just drop the shim right in here. By the way, that's that oil guide plate that I was talking about. If you don't lift the rear housing off straight, you'll break that. And then, to drop in this outer bearing race, you got to drop it down concentrically, nice and even, and it should just drop right in like that. And again, that needs to be coated with MTF as well. Then, prior to putting this thing on, I'm going to clean up this flange real quick. Drop a little acetone on here. I'm just going to clean up this flange real quick. Just make sure there's no debris on here. And actually no oil or anything like that on there, because it will change the preload if there's stuff on there. You can do that to the other side as well, on the rear housing. Clean this up. Okay, now we're all cleaned up. I'm going to put the rear housing back on. Make sure you line the pins, try and get it as flat and straight as possible, and it should drop right in. Boom, just dropped right in. So now we're going to put our bolts back in. I like to put in the long bolts first. Here are the long bolts right here. These are M8 by 1.25, and these are 50 millimeters long. Long bolts go right here and over on this section right here. Those are the two locations for the long bolts. I take those all the way down snug by hand only, and then I'm going to put in the other 6. And I'm going to snug these as well. All by hand. Okay. Now, as soon as I get all these guys down, I'm going to run torque on these guys. I'm going to adjust my torque wrench to 10 pound-feet, and I'm going to do it in a specified pattern that's called out by the manual. So the first one is this guy over here. So I'm going to hit this right here. There's a nice click. And the second one, there's 2. Number 3 is up top here. And number 4 is on the bottom here. 4. And number 5. 5. And 6. There's 6. 7, top corner. Number 8 at the very bottom over here. Okay, so that's at 10 pound-feet. Now you want to do that at 15 pound-feet and at 20 pound-feet, and then you're all set. And then you'll check the running torque. Okay, I have one final note on the bolts that are used OEM. So the preload adjustment may take a couple times, maybe a few times, to find the correct shim thickness to meet the running torque of this shaft over here, of the secondary shaft. Be advised that the OEM bolts weren't meant for reuse. After applying the OEM torque of 20 pound-feet multiple times on these 8 bolts here, a number of the bolts exhibited a phenomenon called necking, or the bolt yields and stretches. Here's what it looks like. See this section right here? It's thinner and the threads are actually stretched in that section. As the bolt is torqued, it actually feels as if the threads are being stripped in the aluminum here, but it's not. It's actually, this bolt is stretching. So I purchased some new bolts. The bolts that I purchased were from McMaster, and I'm using a flange head cat bolt, which is the exact same thing that comes from the factory. See the cap head, right, or the flanged cap head here. And this is a M8 by 1.25, and the long ones are 50 millimeters and the short ones are 40 millimeters. And this is also zinc plated. It's also a class 10.9. You can kind of see the 10.9 right there. And the 10.9 has a minimum tensile strength of 150 KSI, which is equivalent to a grade 8 bolt. So anyhow, just make sure that you change out these bolts, because you're going to run into this problem when you check this several times. So in summary, that's the preload adjustment for the secondary shaft. In part 7, we're going to be looking at the main shaft thrust clearance adjustment. And thanks for watching. This is A to J, out.